Hi, my name is Daryl Barnes with Barnes Basics, and we're going to do another kinematics problem. This is kinematics problem number 2, and the focus is on acceleration. And in the problems that we're going to do, we're going to assume acceleration is constant, not speeding up or slowing down. That kind of makes these problems a little bit easier to do as we go along. Another note before we get started, in the TI-84 Plus, this model right here, TI-84 Plus C, I have across the top normal, fixed 6, decimal, real, degree, and MP. So if you don't know what this means, please go back to the first video in this playlist and I explain how to set this in your TI-84. In your TI Inspire CAS, if you go to Home, and if you go to Settings and click on that, and then go to Document Settings, click on that, there is a list of document settings. The modifications that I think that I made are float 6, degree, and approximate. I think everything else is the same as the stock program for each individual document setting. So that's something to think about. Remember, when we're working on the CAS, we're working with the bottom left multiply, divide, minus, plus key, not the scratch pad calculate. So you can go ahead and open your document there in your TI Inspire. I have tried to think as I'm writing these problems, how can this be fun? And I walk to school, it's about a half-mile away, and there's this little Pomeranian dog that every once in a while tries to get bossy with me. And so this problem is based on that incident, and I have a YouTube video called Attack of the Pomeranian. And so in the comments under this video, I'll put a link to that, and you can actually see the thing that kind of inspired me here. On the very first problem video, kinematics number 1, I think I also, in the comment section, I put something, buzzards in the neighborhood, and maybe something like butterflies and zinnias. Those are some things I have seen on the way to work. So kind of adding a little bit of a different angle, not just working problems, but to get the story behind it. So in this problem, it says the Pomeranian dog slowed from 3.0 meters per second as it ran northward across the street to stop a distance from the pedestrian on the sidewalk, which happens to be me. What is the acceleration of the dog? Well, what I try to do when I look at a physics problem is I automatically just try to read the problem and determine what is this trying to tell me. And in the initial part of the sentence, it's telling me the initial velocity of the dog, and it's giving me the direction. So I'm going to go ahead and write V sub I, initial velocity, as 3.0 meters per second, and I'm going to put it in a direction of north. Typically, this is what the dog does. It will run across the street and then stop and bark at me, is what it usually does. And so it says, as it ran northward across the street to stop a distance from the pedestrian on the sidewalk. Here's another key word, stop. That means that the final velocity is equal to 0 meters per second, and it's still in a direction of north. The dog doesn't always take a direct route to me. Sometimes he'll kind of circle me, but just to keep it simple for this problem, we're going to say that this is what happens. And it says that it happens over a period of 2.0 seconds. All right, I left that out. The Pomeranian dog across the street to stop a distance. Okay, let's say this, over a period of 2.0 seconds. Okay, let's add that in there. That's important. We have to know that. So, time is a scalar quantity. It doesn't have a, well, it actually only goes in one direction, doesn't it? But we don't give it a direction on north, south, east, west, or an X, Y, Z. This happens over 2.0 seconds. The formula that we use is acceleration is equal to the final velocity minus the initial velocity divided by time. So as we have defined each one of these units, all we have to do is just plug into the equation and crank it through the calculator, and I think we will be done. This is a pretty simple problem. The final velocity is 0 meters per second, and the initial velocity is 3 meters per second. We're going to divide that by the time, which is 2.0 seconds. And so when we put this into our calculator, let's do it with the TI-84 first. So we're going to hit on, and we're going to hit clear. On is at the bottom left, and clear is at the top right of the keypad. And we're going to say 0 minus 3.0, enter. And I got negative 3.00 trailing here, divided by 2.0, and hit enter. And I get negative 1.5. I get negative 1.5, and because we've got it fixed 6, I've got several decimals behind here. Okay, I've got 5 zeros showing. Okay, that's what I've got. And let's talk about the units for just a minute. This is kind of important, and this is might get a little congested on the board, but it's okay. It's worth it. When we work this problem out, basically, here's what I want you to see that happened. On the top, we wound up having 3.0 meters. It's going to be a negative value per second. And on the bottom, we have 2.0 seconds. Might be a little bit confusing, but just bear with me. So as we divide negative 3 divided by 2, we get negative 1.5000 with trailing zeros. But our unit is the meter per second, or the meter per second squared. So meters over second squared is how we report this. Now, also remember that we started out with two significant figures here. Remember, we have a whole number and a zero trailing a decimal to the right of a whole number, so this one is also significant. 2 sig figs here. So our answer should have 2 significant figures. So if I was going to kind of bust this out in the best possible scenario, I would drop this off right here. And I would show my work. I would not erase like I'm about to do. Maybe we can go backward. Let's go over here. Instead of modifying that, because it's always important to show our work, let's say that our final answer would be negative 1.5 meters per second squared. And let's circle that. That is the acceleration. Remember, too, because it is negative, that means that the dog is slowing down. If it's a positive acceleration, that means the dog is speeding up. Let's do this on our TI Nspire, and we'll be about done. So we're going to hit home, and let's get to the main screen, and then let's tab. Use your nav pad to tab until you get to the bottom left where it says multiply, divide, minus, plus, and then click on that, and that will get us the page that we have already configured like this. If you're doing a new page, you may need to configure this again, but I'm already in the page that has been configured. So let's crank this through the TI Nspire. We have 0 minus 3.0, 0 minus 3.0, and let's hit enter. And I did something wrong. Let me go back for a second. Let's hit clear. And let's try this again. 0 minus 3.0 and hit enter, and I get -3 on the top, which is pretty basic. Divided by the time that transpired, 2.0, and I hit 20, so hit delete, use the clear button right here, 2.0, and hit enter, and I got -1.5 meters per second squared. So, good job. This is a very simple problem. It's kind of conceptual, I would say. A few things that need to be noted, and I almost forgot and left this out. In a vector quantity, we have to write the direction. And so the acceleration is -1.5 meters per second squared in a direction of north. So let's write that in right there. That is important. So in this problem, we looked and read the problem. We looked and tried to identify the different features that were the variables. 3 meters per second, northward, that's important. Final velocity, the word stop indicates no velocity. Time, I actually left that out right at first, so we got that written in. A period of 2.0 seconds. When you're working problems on a test, you're not going to have the teacher necessarily supplying you with a formula. You're going to have to pick from a list of formulas. But in this case, we did have initial velocity, final velocity, and time. So if we looked over a formula sheet, we would see that this formula easily solves for acceleration because we have all of these units. That qualifies that equation to be of use to us here. Remember that whenever we finish the problem, we report it in correct sig figs. How do you do that? You look at the original numbers in the problem and look at how many significant figures there are, and then report your answer accordingly. Also make sure your direction is reported. That makes it a vector quantity. Remember that if there was a conversion factor anywhere in this problem, where there's not in this one, but if there were a conversion, you would not use the conversion problem to determine sig figs. Like for instance, if it said 1 km is equal to 1,000 meters, the 1 has 1 sig fig, and the 1,000, 1 with 3 zeros has 1 sig fig, and you would not report your answer in 1 sig fig because of the conversion factor. We don't use conversion factors to determine sig figs. So, maybe a fun thing, go check out this video, Attack of the Pomeranian. I will place that in the comments right under the video, and that'll kind of give you a visual image to go along with this, and hope you have fun doing this, because physics is fun, P-H-U-N, goofy, but it is the truth. Have a good day.